Hello everyone, I'm Feng Cao. I'm the founder of PChain. I and the team accomplished a bunch of the number one things in China or even in the world. For example, the number one asset earning transfer over blockchain in the world, which is also the first financial blockchain transaction in China, the first international patent from China, the first financial blockchain prototype in China. But nowadays, we want to show you our new project that is named the PChain, the first multi-chain to support EVM in the world with 4 very important features. The first is, as we said, is multi-chain. The second is the new algorithm and with the pipeline, sharing pipeline. And the third is the smart data. The fourth is the non-native token supported the smart contract. Okay, here is the PChain Explorer looks like, and you can see many dots in the middle. One dot is a node, and whenever it's shining, it means one consensus is achieved, and you can notice that it's achieved very fast. And in the right side is the new generated block and the relevant information, and also which this block belongs to which chain. So we have 32 validators in this network, in this test network, because many people would know that argue POW is not that good because it costs a lot of computation power. However, the advantage of POW is reduce the communication cost greatly, which makes POW survive and is still the most important consensus algorithm in the public chain. We know PBFT for a long time, especially when we adopt in the alien chain, we adopt this algorithm very often. However, the problem of PBFT is it can hardly support the nodes especially when the number of nodes is exceed 20. So that's why, because PBFT, the communication cost of PBFT is n squared. That means if the number of nodes increase much, the communication cost will greatly increased, which makes the consensus among the validator of PBFT impossible. But nowadays we have PChain, so we have our new algorithm named the PDBFT. P here means the PChain, and D is distributed BFT algorithm. It's totally a new algorithm, and we know we can further reduce the n squared from n and even to log n. So this is what we already achieved through the aggregated signature algorithm. This is a totally new algorithm to combine with the new design of PChain, which makes this very high quality or high speed consensus can be achieved to thousands or hundreds of nodes as a validator. So this is the first page of PChain Explorer, and in the second page of ChainPool, you may see that we have the main chain, we have the chain 1 and the chain 2, and the main chain has different block information. And if you come back, you may find that we emphasize that the main chain has the interoperability capability with the child chain, because many people may argue that the child chain and the main chain is nothing new, but we are arguing that through this kind of new design, the better interoperation between the main chain and the child chain can be better achieved. For example, if we compare with the Lightning network, Lightning builds the channel between different accounts and connected the channel together, build the Lightning network. However, the main problem is the account in one channel can hardly use in another channel, which makes the token transfer among different channels impossible. However, if we have a main chain and child chain, whenever we deposit a token from main chain to child chain, the account, if you have a token in child chain, it can be transferred to any another account you want in the child chain. This is a very simple example of how interoperability can be achieved between the main chain and child chain. And at last, we can see the validator. The validator are shared among different chains. For example, the main chain and the child chain. But also, we need to do a lot of further things to be done. For example, the load balance of different validators, the load balance between the child chain and the main chain. Okay, nowadays let's look at the new Oracle mechanism provided by pChain through smart data. Traditionally, we know Ethereum provides this kind of capability through the smart contract. However, smart contract itself is not designed for the Oracle. But nowadays we know that because the smart contract rely on a bunch of external data, which means the smart contract is open loop. Through this very simple smart data capability to provide Oracle mechanism is not that efficient and not cost much. For example, the data provider need to continuously push the new data into the smart contract to make it available, but very often it will cost the data provider to do this kind of things, and also the frequency of data update is not that efficient because it will need to wait for the new block generation. So we design a new mechanism in pChain called smart data to improve this kind of situation. So you can see here we have the World Cup Casino smart data right by Solidity. This smart contract, one of the keys is the construction function, that is the World Cup Casino function, which in this construction function we define the entity of that is the World Cup final, which is the subject of RDF, and also attribute the 2014 champion. This is the predicate, and also we define the relevant team, that is red team, the blue team, and also one of the key is the source, that is Oracle source. We defined it, and through the SD sources function to define this. Another important function of this smart contract is called release result, and one of the key function inside of it is a new function provided by us, that is the SD value. In SD value, we define the entity, define the attribute, and also the source to retrieve the result. That's the object of RDF. So through this kind of extension to smart Solidity language, we can easily write a new smart data powered smart contract through this. What if we translate this Solidity smart contract into a Zenbolt code ASM file? It looks like here, and you can see that one of the difference is we extend SD value operator in this new operation, which we already accomplished to extend the operational code of EVM. Let's say how to debug this ASM file in a console. Here we input the code and return. At first, we will get the string of 3wfifa.com, and then we get the offset of this set, and finally we really push it into the memory. And similar things will happen for the subject, that is the World Cup champion, World Cup final, and the similar things happen to the predicate or the attribute, that is the 2014 champion. And then we through 5 or 6 push operation to really push this things into the memory. And then nowadays we come to a very important operator, that is the SD value. And the SD value here, you may notice that in the last we have a 1 number here. That means it's already successful retrieve the data from the data sources we defined in smart contract. And in the next, the system will also generate the further operator on a if condition to check whether it will go through another address or not. The address here is the 4C here. Remember this, and here you can see the jump operator, and also you may notice it costs much, which is defined by the EVM. We just follow it. And nowadays we really come to this address, that is 76. This is the decimal address of previously 4C. 4C is the hex format of this address. And then we come to the really retrieve operation, and at first we will define the size of the data to be retrieved and also get the offset of this data to be retrieved. And after that we set the buffer offset and also the memory offset of the result. And then finally, okay, here you see we get the final result. That is German win the World Cup final in 2014 Champions League. This is a very simple example of how we can write a smart contract through with the extension of smart data, and how this smart contract is compiled into as ASM file, and how to debug with the new generated ASM file with the extension of the operational code. So that's all of our demo. In short, we demonstrate the new consensus algorithm with the multi-chain design and also the capability provided by the smart contract. In fact, and with the smart data. Thanks for your time. That's all of our update of our progress. Because many people ask if it's MVP. In fact, we never claim that it's MVP. We call it prototype. So even though you see a lot of progress we achieved, but I want to highlight that we are still in very early stage of project. So if you are really interested in this project, welcome to follow our Twitter, that is pchain_org. Thank you.